Good afternoon. I'd like to begin our talk this afternoon with a land acknowledgement statement. As a land grant institution, the University of Illinois has a particular responsibility to acknowledge the peoples of these lands, as well as the histories of dispossession that have allowed for the growth of this institution for the past 150 years. We're also obligated to reflect on and actively address these histories and the role that this university has played in shaping them. This acknowledgement and the centering of Native peoples is a start as we move forward to the next 150 years. The title of our talk today is Climate Change and the Future of Water in Illinois. And it's be presented by Dr. Trent Ford, who's the Illinois state climatologist. Dr. Ford has been the state climatologist since 2019. He and his team provide information online through traditional and social media and by speaking to interested groups across the state, such as us. In addition to his role in education and climate outreach, Ford also conducts research on the climate system and extreme climate events like drought and heat waves, which we've seen plenty of this year. He monitors current conditions and studies climate change. I'm really looking forward, Dr. Ford, to what you have to say this afternoon. Thank you so much for being with us.
Yeah, thank you for inviting me. I'm just setting, I have one nice thing about virtual presentations, probably the only nice thing is I can set my stopwatch on my phone so I don't keep rambling over time. Thank you for having me. Yeah, this is really great. I'm really excited to be here and discuss climate change with you all. And Elizabeth asked that I kind of focus on the future of water, especially as it relates to climate change in Illinois. So I'll be talking more about water than temperatures, but we'll roll temperatures in there as well. So I have to start with the science behind climate change, very brief. This is a schematic from NASA that shows a simplified version of Earth's energy budget. And as it boils down to it, climate change and its primary driver, global warming, it's an energy issue, really. So certain gases in our atmosphere allow the sun's radiation to come in and affect the Earth's system, but absorb the outgoing terrestrial radiation. These gases are called kind of metaphorically as greenhouse gases. They work similar to a greenhouse where they can trap that energy and thereby regulate Earth's energy balance. Now these gases, carbon dioxide, which is CO2, methane, CH4, and then the gas form of water, they occur naturally on Earth and they vary naturally over long time scales, but they can also change the concentration or have their concentration changed both due to natural causes and what we call anthropogenic causes, those that are due to humans. What we've seen since we've been consistently measuring carbon dioxide concentrations in the atmosphere at Mauna Loa, the observatory there in Hawaii, is a consistent increase in carbon dioxide concentrations, at least over the last 50 to 60 years. Now you'll see here at the bottom of this chart here on the left-hand side, well, when we started this observation back in the 1950s, we're at something around 315 parts per million. That's a volumetric measurement of carbon dioxide. Just last month's average was 414 parts per million. I have this slide hidden for time reasons, but if I were to show the long-term observed record from ice cores going back almost a million years from Antarctica, we see carbon dioxide concentrations never reached over about 315 parts per million in the last million years. And we've increased that by about a third, up to 400 parts per million in just the last 50 to 60 years. Now, the reason I'm focusing on carbon dioxide here is because although methane plays a really important role, as does water vapor, carbon dioxide drives the bus. So when you hear of the COP26 meetings, when you hear about climate change, it always comes back to carbon because carbon dioxide for Earth's entire history has been the main driver of temperature and energy balance on Earth. So what has this caused? Well, we know even without the effect of humans that when carbon dioxide concentrations go up, temperatures go up across the world. When carbon dioxide concentrations go down, temperatures go down. So because of the increase in CO2 in the atmosphere over the last 50 to 60 years, whether you can go back to the Industrial Revolution 150 years ago, we've seen a consistent and significant, very rapid increase in global average temperatures. That's what's shown here on the left, combined with the reconstructed record going all the way back to 1 AD, the year 1 AD. The warming that we've seen over the last 150 years is unprecedented in more than 2,000 years. And when we go back with the ice cores going back several 100,000 years, we see that the 20th century was the warmest century on record in more than 100,000 years. Now, as far as a total increase in greenhouse gas concentrations has caused about 1 to 1.5 degrees of warming relative to pre-industrial. So before the Industrial Revolution, we've increased by 1 to 1.5 degrees Fahrenheit. Now, that's the global average. And a lot of times people look at that number and say, it's not really that much. But in reality, to increase the global average temperature by even just a degree Fahrenheit takes a tremendous amount of energy. Because the climate system is so complex, everything is interconnected. It makes it quite challenging to study. What that means is that a change in energy on Earth that results in a 1 degree Fahrenheit increase creates dramatic changes in regional climate. One important thing here, this last bullet point here on the left-hand side, this is not the musings of a random state climatologist. This is taken straight from the most recent IPCC AR5 working group report that was released in August. Virtually all of the warming that we've witnessed since the Industrial Revolution is due to human activity. That's really important because that has been debated over the last 30 to 40 years quite intensely. In some pockets, it still is debated, but basically climate scientists together say, no. Virtually all the warming is due to human activity, and there is very, very high confidence in that. So what sort of human activity, you might ask? Really energy creation. That's basically what it boils down to. What I'm showing you on the right-hand side, that is a breakdown of the sources of greenhouse gas emissions in 2019. I should say there's a couple of caveats to this. So we see the big hitters that we know about. Transportation is roughly 30% of all US emissions, and it's a little bit of a higher percent globally. Electricity production, industrial processes, we have commercial and residential use of energy, and then we have agriculture. Again, a couple of things here. If we were to take this all the way back to the Industrial Revolution, we would see that industry and electrical production make up the bulk of historical emissions of greenhouse gases. Transportation has been increasing in the last decade to 2 decades and is now globally the major producer of greenhouse gases. Also, this 10% from agriculture is a bit misleading because that is 10% of all greenhouse gases put together. When we just include methane, which is a pretty powerful greenhouse gas, agriculture creates the majority of methane emissions. And when we go outside of the United States, especially in developing nations, where deforestation takes place to make for either monoculture agriculture like palm oil production or grazing for cattle production, we see that agriculture makes up a much larger chunk of greenhouse gas emissions globally. And what you see here is that on the left-hand side, this is showing from the US what land use change in forestry, and what that does to offset greenhouse gas emissions. So overall, land use, especially naturalized land use, can act as a sink for carbon, but the effectiveness of land use cover, afforestation, reforestation, doesn't even scratch the surface for our overall emissions. But that is important to understand that we do have land use cover counteracts emissions, but not to a large degree. Okay, so I'm going to move right into impacts that we've seen here in Illinois. All right, so global average temperatures increase. What that does is it changes regional climates, and we have seen significant changes here in Illinois. And because, again, I'm focusing on water, I'm going to talk about precipitation changes. Just to give you a small summary, we've seen temperatures increase across Illinois, across all seasons. But I would say really that changes in precipitation that we've seen over the last 100 years in Illinois have constituted the majority of actual impacts, whether it be to urban and residential areas, to agriculture, to naturalized systems. So no surprise to anyone probably is that we're getting wetter here in Illinois. I'm showing you on this plot here, total annual precipitation for the Central Illinois Climate Division. And we can see an increasing trend over the last 125 years of about ½ inch per decade. So overall here in East Central Illinois, we're about 4 to 5 inches wetter per year than we were at the turn of the 20th century. When we break that down by season, what we can see here is that we've seen the majority of that increase in spring and summer. All seasons have gotten wetter. Spring and summer have gotten wetter to a largest degree. Now, more precipitation overall, especially when we're considering a trend as, arguably small as half an inch per decade, doesn't necessarily create impacts in itself. What has been changing has been so impactful is the characteristics of that precipitation. Now, rainfall intensity, precipitation intensity is a very challenging topic to communicate. Not because it's controversial, because it's just complicated, let alone talking about changes in rainfall intensity, right? Like I could tell you, like I did before here, this plot, yeah, okay, it's getting wetter, and this makes sense, ½ inch per decade. We get about 4 to 5 inches more per year here in Champaign area than we did at the turn of the 20th century. That all makes sense, right? But when we talk about rainfall intensity, especially at sub-daily intervals, it becomes really, really challenging. So one of the ways that I've found that is one of the most effective ways at communicating the intensity of the intensity of rainfall, how it's linked to climate change, and the risks that it poses, is to discuss climate change in the context of recent events that we've seen. And I update this table. I can't, it's amazing. When we think about the state level, I can't even update this table quickly enough with the number of intense precipitation events that we're getting. So there are a couple that I want to focus on. For example, last summer in Peoria, we had a really intense rainfall event. Down in the Metro East area at Belleville, Scott Air Force Base, they had one in August. And then 2 this year in our region, one in it's just south of Bloomington, between Bloomington and Hayworth in June. And then of course the really intense Gibson City event in August. Now, what I have here on the right-hand side are estimated return intervals. And this is really important for development. Infrastructure creation is, building stormwater drainage, building landfills, building buildings to withstand an X year rainfall event. Just the same way we think about like the 100-year floodplain or the 500-year floodplain, we can think about a 100-year rainfall event, right? The return interval of that rainfall event. So those were originally estimated by a study in 1989 that was co-authored by my predecessor, Jim Angel, Bulletin 70. And because of the recognized need to update those intervals, there was a recent update to those Bulletin 75, those recurrence intervals, just a couple of years ago in 2019. So what that gives us is 2 snapshots in time to say, okay, these sorts of events that we've seen, how is the frequency of these sorts of events and the impacts, of course, they cause, how is it changing? So for example, just this year in June in Bloomington, they got south of Bloomington, between Bloomington and Hayworth there in southern McLean County, they got almost 10 inches of rain in 3 days. Really intense event. Based on the 1989 estimates, we see that's over a 500-year event. So what that means is that based on that data and as current as of 1989, that has a probability, a 0.2% probability of occurring any given year. So very relatively low risk as far as that sort of event occurring and the impacts that it creates. Based on the new estimates of 2019, it is a 250-year event. Now, still an extremely rare event, but what that means is with the inclusion of the last 30 years of data since 1989, the probability of that type of event occurring has doubled. And so what that means is that we're seeing these very intense rainfall events happen more intensely. We're getting overall more rain in a short period of time, but they're happening more frequently as well. The Gibson City event that we saw, we saw more than 10 inches of rain in 3 hours. That was an event that I hope that I go the rest of my career without seeing again. And it's very possible I can. That was in such an extreme event that it's hard to necessarily put a recurrence interval on that. The National Weather Service estimated possible some places over a 1,000-year event. But with these other events, what we're seeing is that the frequency, the risk that we're getting that really intense precipitation is increasing. And it's increasing over a relatively short period of time. Again, between 1989 and 2019, we're talking about, less than one lifetime. We're seeing a double, and in some cases quadrupling of the risk or the frequency at which those events occur. So what does that cause? Well, when we think about flooding in Illinois, often we think about our big rivers, the Illinois, the Mississippi, the Sangamon, the Kankakee, the Big Muddy. These are of course, when we get really heavy rainfall for a long period of time over watersheds, we can get flooding along riverine areas. But what we've seen even more than that is intense precipitation, not necessarily over weeks to months, but just over a number of hours to days, causes a different issue, urban or pluvial flooding. That's flooding that is likely outside of a floodplain and is caused by the fact that there's just not enough drainage, whether it be from lackluster stormwater drainage systems, sewer drainage systems, or just topography of an area that causes the water to back up. On the top, I'm showing an image from Gibson City there. You may recognize the McDonald's sign at the corner of 47 and Route 9. And then on the left, bottom left here is an image from a neighborhood in Bloomington. Now, both of these areas are outside of the mapped 100-year floodplain. So again, we think about flooding as is at risk of folks who are in floodplains, but because of the intense precipitation, we have the risk of urban flooding that comes from that. So, we've seen more precipitation, more intense precipitation here in Illinois. What do the projections tell us? What do models tell us is going to happen in the next 50 to 100 years? What I'm showing on the top of the maps here on the top are showing the projected change or increase in the number of very wet springs. There's numbers for that, but we consider the number of very wet springs. From left to right, it's the historical on the left frequency of very wet springs, and then the projected change by mid-century, about 2050, and the projected change by late century, by 2100 or 2080. And then on the bottom, we see dry summers, and I'll get to drought here in a little bit. What we see is consistently between models, projected 3 to fold increase in the frequency of wet springs. So we can think about a wet spring as something like, for example, 2019. When we had across the whole region in extremely wet conditions that caused, of course, widespread flooding, especially in floodplain areas and delays to agriculture, really significant impacts there. So we see an increase, projected increase of about 3 to 4 times the frequency of those sorts of events. So extremely wet springs. And I think somebody had mentioned in the business meeting ahead of this that that they were going out and supposed to do some survey or tours in a river, and it just rained really hard in spring. That's becoming more frequent, where it's much less likely that we get a near normal or dry spring. And when we talk about dry summers, we don't really see that same sort of projection. There's been a lot of statements made mulling around that summers are going to get drier here in Illinois. And there's a lot of uncertainty in that. We haven't seen that in historical observations. As I mentioned earlier, summer is getting wetter at a faster rate than any other season. And when we look at the projections, they're really not showing that consistent increased frequency of dry summers. And really the models are sort of all over the place. Some project a really large increase, some project a really large decrease as far as summer rainfall. And so we kind of have to kind of shrug our shoulders right now and improve model development to give us a better idea of what we expect for summer. But on the flip side, for spring, they're all showing the same thing, an increase in spring precipitation overall. So what do springs mean? Well, for example, I'm showing the impacts of 2019 on the left-hand side. This is from Freeport, when the Pecatonica overtopped its banks and caused some significant flooding in March 2019. We can go back to 2019. The map on the right-hand side shows the percent normal for total March through May precipitation. And you can see parts of Illinois were anywhere between 125 to 200% of normal rainfall for an entire season. And of course, the whole Midwest was experiencing those problems. So it wasn't just us, but upstream was really wet as well. These new estimates that we have from this new study suggest that spring 2019 precipitation totals have an estimated 5-year return period from the latter half of this century. So where 2019 precipitation totals historically have happened 1 out of every about 30 years, projected to occur 1 out of every 5 years. And so this is really something I know a lot, again, a lot of times we hear about drought issues, and of course drought issues are important, but I would say that one of the biggest challenges from changes in our physical climate here in Illinois, along with changes in temperature, especially in winter and summer temperatures, is this issue of wet springs. This is an issue that we've seen a significant increase in over the last 50 to 60 years. And the models are telling us, again, with fairly high confidence, that this is something we're going to continue to see into the future. So I mentioned drought. Drought's a tough one. I could give a whole hour-long presentation on just the changes in drought and the uncertainty that we have. So precipitation has increased across Illinois. And overall, that's made for fewer long-term drought events. We haven't seen multi-year drought events like we saw in the 1930s and 1950s. We haven't seen that in arguably 40 to 50 years. The droughts of record that we think about are 2012. That was a 1-year drought. In 1988, again, a 1-year drought that caused significant impacts, mainly to agriculture and ecosystems, some water resources, but then the following years were fairly wet. So one thing we are seeing as far as impacts of drought, considering that summertime precipitation projections of what's going on in the future are really uncertain, one thing that we do see is that the models tell us that summer temperatures are going to continue to increase. We're going to see hotter summers overall. So what that does is it increases the demand, the atmospheric demand for water from plants. And so I'm kind of showing that on the left-hand side here as a form of vapor pressure deficit. Now, vapor pressure is basically the vapor pressure deficit, basically one way of thinking about it is representing the demand for moisture of plants. So if the air is very dry and warm in the summertime, it will demand a lot of evaporation from or transpiration from plants' leaves, which, if given the right conditions, can cause some significant stress, both for agriculture, crops, but also for our natural ecosystems. And there's been a lot made about this idea that because temperatures are increasing in the summer, vapor pressure deficit is increasing as well. So even without changes in precipitation, we could see more evaporative demand kind of driven drought impacts to vegetation in the next 50 to 100 years. However, what we've seen in the summertime is that minimum temperatures, nighttime minimum temperatures, have increased at about 3 to 4 times the rate of daytime maximum temperatures. So summer nights are getting much, much warmer at a faster rate than summer days are. What that means is that vapor pressure deficit is essentially flatline, going all the way back to the 1970s. So that's why I'm showing you here. Just pulled a point out at Monticello in Piatt County of average summertime vapor pressure deficit. The higher the number, the higher the demand is, the higher the stress is on plants. And we can pick out these drought years, right? 2012 is just ungodly as far as evaporative demand is concerned. 2011 wasn't great either. 1988, of course. But in recent years, we've seen relatively low evaporative demand. We haven't seen that. And that's because our humidity is still high enough that it really offsets the impact of higher temperatures. So this is something I give you this to tell you that drought is really complicated, especially as it relates to drought impacts on agriculture, drought impacts on natural ecosystems. And we don't really have a good signal of how drought will or will not change in the future. I will say that drought, including multi-year drought like what we got in the 1930s and 50s, is a part of our natural climate here in Illinois. So when I try to give this, this talk to folks in agriculture, I'll tell them that, yeah, the risk of long-term drought has decreased because precipitation's increased overall, but we will still get a drought. We'll still get another 2012. We'll still get another 1988. I will guarantee that sometime in the next, 30 to 50 years, because that's part of our natural climate. However, when we think about climate change, its impact on drought, it's really uncertain in the Midwest here. Okay, so I've talked a little bit about impacts, but I'll get a little bit more specific into impacts to different sectors that we've seen and are likely to continue to see here in Illinois. One thing we talk about a lot are impacts from physical climate. So, too much water, not enough water, high temperatures, low temperatures, storms, all that sort of thing. But this all has to be wrapped in the idea of social vulnerability. So what I'm showing you here on the right-hand side, this is from the BRACE program at the University of Illinois, Chicago, which is an offset of the CDC. And it's showing, these different counties in Illinois color-coded by overall social vulnerability. So the darker the red, the more social vulnerability we have in that county to changes in our climate. And we can see in the region that we're talking about here, of course, we have Vermilion County, which is among the highest as far as social vulnerability is concerned, relative even just to Iroquois and Ford County. When we break it down for Vermilion County on these maps here, the darker the areas here on these maps, the higher the overall social vulnerability. We can see those areas of Vermilion County, especially the urbanized areas around Danville, that's where we have the highest social vulnerability. Now that's defined in a lot of different ways. It can be socioeconomic status, so how basically your affluence and how many resources you have to reduce your vulnerability to the impacts of climate change. Household composition, disability, of course, and accessibility is a problem when it comes to adaptation and resilience to climate change. Accessibility to transportation, language barriers, all of those things add up to overall social vulnerability. And again, I just show this to you to get this idea of, the impacts of climate change for our kind of 4-county area, Ford, Iroquois, Champaign, Vermilion. They don't really vary a whole lot. It's not like Southwest Champaign County is going to see a lot more storms than Northeast Iroquois County. It doesn't occur at that scale, but social vulnerability does. We definitely see a difference in the overall vulnerability to those impacts that we need to keep in mind. So flooding, I talked about flooding. It's really important. And again, when we think about social vulnerability, it has these disproportionate impacts. I use the example from the city of Chicago just because there's a lot of data there. So flood insurance claims just in the Chicagoland area, so that's the surrounding the 7-county Chicagoland area, have increased exponentially over the last decades. Payouts since 2011, and this data is current as of 2020. So just in that 10-year period, payouts for flood insurance totaled $400 million in that 10-year period. Of course, as we know, flood insurance is backed by the federal government. Between 2007 and 2016, almost 90% of flood damage insurance claims were paid in communities of color. And if we know anything about the geography of the city of Chicago, what we see here is that the effects, the impacts, the vulnerability, if we can say that, to things like flooding are felt disproportionately on communities of color, poorer communities, those that have less resilience overall to flooding. So again, it's not like the far west side, the far south side areas of Chicago are much more likely to experience heavier precipitation than the Loop or the near west side, things that are more affluent neighborhoods. It's that overall there's built-in vulnerability to our infrastructure that makes these areas more likely to experience the overall impacts from things like flooding. And of course, we can bring that down to the Champaign-Urbana area as well. We can map out the neighborhoods of Champaign and Urbana that have a higher likelihood of flooding. Even if anytime we get a 2-inch or more rainfall event in the Champaign-Urbana area, we know what areas are going to flood. And again, it overlays with a higher likelihood of those areas being communities of color. So other impacts from intense precipitation, soil erosion. This is an ag impact. This is a natural ecosystems impact. There's new estimates from a new study this year that suggest that 30 to 50% of that organically rich A horizon has been lost in the Midwest since the 1800s, since European settlement. And that, of course, it creates a serious issue. We're losing that really rich organic soil, that topsoil that we can thank for much of our lifestyle here in the Midwest. And so that, of course, it creates an issue when we think about the productivity and the health of our natural ecosystems, the productivity of our agriculture. It also creates water quality problems. I'll talk to that just in a little bit. It's not just soil that's running off when we have that intense precipitation. It's nutrients that we want on our fields, nutrients we want in our natural ecosystems that are running into our water, nitrogen and phosphorus, namely, that create serious water quality issues as well. And we saw from the recent nutrient runoff report that this is getting worse in Illinois, despite all of the successes that we've had in implementing soil and water conservation, and despite all of the coverage, the awareness of these issues, it's getting worse. And part of that is due to increasing precipitation intensity. As I mentioned, with water quality, we see more intense precipitation yields more runoff. And of course, we have, again, issues with that with natural ecosystems. We have areas that are flooded because of increased runoff that shouldn't be flooded. Plants, native plants that are more apt to drier spots that are being inundated more frequently, causing issues with plant health. But we also see water quality issues. So between the 2015 and 2019 nitrate load statewide was 13% greater than the 1980 to 96 baseline loads. Now there's reasons for that, and it doesn't mean that everywhere in the state is getting worse. There are parts of the state that are getting worse than others as far as nitrate load, but it is a problem. We've also seen larger increases in total phosphorus. That is, again, likely related to increased river flow plus increased tile drainage. Now, of course, our soil and water conservation techniques, I'll talk about in a little bit, are major ways of reducing this issue, reducing the amount of soil erosion, reducing water quality issues. But even as we implement those strategies, and I know a lot of the work that you all do is really important for that, we're still fighting this issue of climate change. So even without climate change, this would be an issue just because of the predominant land use here in Illinois, but climate change makes this all worse just because we're seeing increased precipitation intensity. Some climate change impacts breaking out to things like forest ecosystems. We have some serious issues related to our forest ecosystems. More runoff from ag fields. Of course, we have issues of pesticide runoff, herbicide runoff, and then pesticide drift that becomes an issue. Increased disease from just more frequent inundation from water, things like oak blight. We also have drought stress on mesic species. So I talked about the overall reduction of the risk in long-term drought, but we still get drought. Talk to folks in Northern Illinois this year. It will remain to be seen. We'll see what sort of impacts to naturalized ecosystems in the urban canopy we saw from this year's drought in Northern Illinois. It is likely to be significant, especially for those urban trees that don't get water. And so again, even though we're getting a weather climate overall, drought is a natural part of our climatology. We experience that in Northern Illinois. So mesic species like red maple, sugar maple, et cetera, the drought stress that comes from natural variability on top of more inundation from more frequent flooding really becomes an issue. And then warmer and overall drier conditions in some places, but especially warmer conditions, may exceed species ecological tolerance. And these are really important species. We're talking about white oak, black cherry, shagbark hickory. These are stalwarts of both the mixed hardwood forest and savanna systems that we see here in Illinois. And again, especially in Southern Illinois, where we're seeing warming conditions, projections of increased temperature getting up to that place of these ecological tolerance of these species, it becomes an issue. One thing I wanted to mention when it comes to forest ecosystems is that, and the impacts of climate change, is that, we think about the impact of climate change on forest ecosystems as just extreme weather. More short-lived but intense drought could create fire issues, higher temperatures, more variability, more intense precipitation that creates, inundation and things like that. But it's sort of a double-edged sword, because the same time that our climate is changing here in Illinois, making it perhaps less conducive for certain native species of trees and species in our forest ecosystems, that climate change is also making more conducive environment for certain non-native and invasive species. And so at the same time that some of our native species have to deal with changes in extreme weather, they also have to deal with increased invasion from native species, or increased encroachment from non-native or invasive species. I like this study here from Aronson and Handel in 2011 that showed how these different species, we have oak, maple, and ash, how the survivability rate of seedlings changes depending on whether or not a really intense non-native invasive species, Japanese stiltgrass, is present in that area. So the dark bars are showing here are without Japanese stiltgrass, that seedling survival rate, and the light bars are with that. And we see, again, especially for oak and ash, that we get a really significant decline in the survival rate of seedlings of those tree species when we have the presence of that non-native invasive species. So again, it's not just the extreme weather, but the fact that our climate, whether it be warming winters, more wetter climate overall, making more conducive environments for some of our nastier non-native species that compete with our really beneficial natives. And I should say also that we think about this as naturalized landscapes, but the same factors are really important for the urban canopy. We talk about green infrastructure as being so important when it comes to adaptation to more extreme heat, to more extreme precipitation. But if we build all that green infrastructure with species that are not tolerant or not resilient to changes in climate, that overall reduces the positive impacts of that green infrastructure. That's also a really important consideration to make. Aquatic ecosystems also see some significant impacts. As you can imagine, as air temperature increases, water temperature increases as well in our streams, our lakes, and that affects feeding, it affects growth, it affects reproduction. Again, this idea of certain species are affected more than others. So cold water fishes, like for example, pike or walleye, they have to migrate north. Because in some of our southern lakes and streams, we're seeing water temperatures that are reaching again that ecological tolerance, whereas some of our warm water fishes are actually could benefit from increased water temperatures. But again, we see non-native invasive species like, for example, bighead carp that also benefit from that climate change. The nutrient runoff that I mentioned before is such an issue when it comes to water quality for our drinking water, of course, is also an issue when it comes to water quality for our aquatic ecosystems. Overall, warmer water plus nutrient runoff from agricultural fields increase the risk of harmful algal blooms in lakes and streams. And it's just it's a real problem. So again, reducing that nutrient runoff is a really important thing for overall building resilience in all of our natural systems here in Illinois. Birds are also affected. This is something that hits close to home because I am a major bird fan. Birds are affected by climate change. Of course, there's an Audubon study that found that almost 30% of Illinois bird species are vulnerable to climate change across seasons. These are really important species like the bobolink, the redhead woodpecker, the brown thrasher, the wood thrush. But importantly, and I really like that the Audubon did this in their study, they looked at, okay, what would reducing warming, what would that do to the overall risk to these species? And it would more than halve, going from 3 degrees Celsius overall warming by the end of the century to 1.5 degrees, would more than have the overall avian risk to climate change in Illinois. So again, it's not just, here's all these impacts, we're all doomed, but hey, we have not a lot of time, but we do have time to make some significant changes to build in resilience and reduce the overall effect of climate change before we see some of the worst impacts. Lastly, some impacts to agriculture. I just put this up here because agriculture is a major part of Illinois. It's the dominant landscape, and we see these impacts. We also see agriculture should play a really important role in adaptation and mitigation as well. So there's lots of different ways we can think about this, but warmer winters have increased survival and reproduction of insect pests as well as fungal diseases. We have winter chill hours that will decrease significantly for some of our specialty crops, apples, peaches, berries. Higher risk of fall spring, more excessively wet soils, which really create issues with planting, and then increases in excessive heat that could really cause some issues, especially with small grains. And in the warm season, we have issues with more competition from invasive and non-native flowering species, issues with weed control. There was a study done by the College of ACES here at the U of I just a few months ago that found that late season weed control in some of our grain fields, corn and soybean fields, namely, is one of the biggest determinants of overall end of season yield. And what we're seeing is that weed control becomes much more challenging with increased precipitation, with increased overall temperatures, and it just makes agriculture more challenging. Also, this is for anybody who likes to be outside. Those warmer winters and the overall longer growing season also makes for a longer biting season from ticks and mosquitoes. We're seeing, just like those invasive species like Japanese stiltgrass and bighead carp, we're seeing the increase in the range of certain tick species that are vectors for some significant diseases. That includes the Lone Star tick, the Gulf Coast tick, for example, that bring all sorts of not great diseases. And so exposure to tick and other vector-borne illness also has increased and is projected to continue to increase into the future. All right, last, that was the doom and gloom. And I try not to do too much doom and gloom and end on the positive note of what can we do? What are we doing? A lot of the things I need to mention, a lot of things you all talked about in your business meeting, they would largely fall under adaptation to climate change, building resilience, and it is extremely important to continue and grow those initiatives. So I should say overall that solving climate change, solving these issues really call for mitigation. Now, the difference between mitigation and adaptation, mitigation goes at the heart of the issue. Mitigation is reducing, eliminating carbon dioxide emissions, going to what's called net zero, basically overall reducing the warming, which absolutely has to happen. It has to happen immediately. There has to be a substantial curbing of system-wide greenhouse gas emissions, as well as removal of carbon dioxide that's in the atmosphere already. That's a global effort. We saw those the COP26 talks the last 2 weeks, but it starts local. You know, there's policies that can be put in place, but it is an overall global effort to overall reduce the magnitude of climate change. That has to happen for us to avoid the kind of worst case scenarios that I've sort of played out in previous slides. However, I should say that one of the biggest things that's touted as how we can help as an individual with climate change is, oh, just, you know, decrease your personal greenhouse gas emissions. Well, you can do that to a certain extent, right? I mean, you can perhaps do things like eating less meat or driving less, using public transit, the way that you manage your landscape or composting, things like that can overall reduce greenhouse gas emissions, but we all have to live. That is a really important part. There is no way to live in this world without emitting carbon dioxide. So I don't like the idea of talking about carbon footprints because there's only so much we can do. Now we can go and lobby for systemic change at the state, at the federal level, push for those changes. That's a really important thing that we can do as individuals. But we're not going to solve this issue by just overall us, you know, quote unquote, doing our part, if that makes sense, by reducing our personal greenhouse gas emissions. Plus, it extends this issue of guilt. You know, if you just want a hamburger, right, or you need to get in your car and drive, or maybe you can't afford an electric car or solar panels for your house, you create this issue of feeling guilty about your quote unquote contributions to climate change. So I like to kind of downplay that part of it. The things that we can do overall, the things we need to do, starts with things like sustainable urban and rural development. So green space, the Red Oak Rain Garden is a really good example of that. I have that picture of that new bridge that was built there. That was really awesome. That's really important. Also, accessible public transportation, right? People are going to drive their cars unless they have another option, right? And making urban areas bikeable, walkable, and having accessible transportation is the best way of reducing that transportation greenhouse gas emissions. Also, water management through engineering and design is really important. So we think about green space like the Red Oak Garden, those sorts of infrastructure developments, the main goal there is to reduce that surge of water that comes from runoff when we get intense precipitation. So as I showed, projections showing that we're going to see more intense precipitation overall. An expansion of that green infrastructure means that it can reduce the overall risk of urban flooding that we see in Champaign-Urbana and Chicago and on areas all over the state. Also, agriculture. Agriculture plays a really important role here. The expansion of soil water conservation practices is extremely important. Now, again, soil and water conservation practices have a arguably small part to reducing greenhouse gas emissions. However, they reduce the vulnerability of agriculture, natural ecosystems, drinking water supplies, water resources. They reduce the vulnerability of those systems to climate change. So they are extremely important. Strategies for agriculture, the implementation of small grains, more diverse cropping rotations, conservation grazing, which is so important for especially here in Illinois, when we can actually, our system can support grazing systems better than, for example, out west. Also, local food supply demand chains. Transportation of food actually makes up a relatively small piece of food greenhouse gas emissions, but creating local food supply demand chains overall reduces vulnerability of food supply to climate change. So for example, right now, something like 90% of our vegetables and fruits nationally are grown in one of the most vulnerable places in the world to climate change, in California. So increasing food supply, vegetable and fruit supply grown here in Illinois reduces the vulnerability that, for example, if they get a huge wildfire in California, that we still have food supply here. Also, natural resource conservation, which you all are so important in. I don't need to belabor that point because you all know the importance of things like habitat restoration, expanded conservation stewardship plans, and again, just better highlighting ecosystem services, right? It's called, and we talk about green space, but green infrastructure is a better word for it because it's just like regular infrastructure, roads, bridges, airports, heating, power lines, right? Trees and our rain gardens, things like that are just as important part of that, and highlighting the ecosystem services that are provided by that is really important to get folks to envision, to let's say, prioritize green space just as much as they do building roads, bridges, things like that. So lastly, here's my last slide, the important role of master naturalists. So all of the things that you all do go to that adaptation to climate change. So, again, that mitigation, the reducing carbon dioxide emissions, that has to happen at the national and global level. That's a policy thing. Adaptation to climate change is a local issue, making sure that, okay, we are going to experience the impacts we have experienced, and we are going to continue to experience the impacts of climate change. So how can we make our local systems, our communities, our ecosystems more resilient to climate change? And I think that you all play an extremely important role in that. Promoting conservation practices, extremely important. Promoting healthy ecosystems and ecosystem services. In the business meeting, you all talked about the education that you all do, which is so important. Advancing citizen science and just interest in natural sciences. Again, if you get somebody out to increase the awareness, the appreciation of ecosystems and the services they provide us, they're more likely to do things like vote for those interests. So that is really important. One thing I do need to mention with citizen science here, I have the CocoRoss map, and you all mentioned CocoRoss, which is great. I use CocoRoss every week in my scientific studies and analysis and communication with state and federal partners. And you can see here that our for the 4-county area, of course, we have lots in Champaign. Thank you all of you for that area. Also in Danville. But we do have some areas that we could increase. So if you live in these areas, Northeast Champaign County, Northwest Vermilion County, basically the whole northern panhandle of Ford County and much throughout Iroquois County, please consider, if you are one of these few people out here, I very much appreciate what you do for CocoRoss. Please convince your neighbors to do it as well. I know that there are people who garden in these areas who have rain gauges up. I see them, I drive through them and I see them. Convince them to just report for CocoRoss so we can get more information in those areas. It really makes a difference in my job. Again, every week I work with that data. Also things you're doing, sustainable landscape development, recreation, all of these sorts of things are really important. And again, re-envisioning our homes, our yards to, again, make them overall more resilient to climate change. I saw so many reports, got calls, photos sent to me of people's yards in Northern Illinois this year, just regular sod, they died. They lost their entire yard. And it only took maybe a month to 2 months worth of pretty intense drought conditions. The reason that happened is because it's not resilient to climate change. It's not resilient to those climate extremes. And so again, re-envisioning our spaces to make us overall less vulnerable to the impacts of climate change and overall a healthier ecosystem. And the last thing is, I really appreciate, somebody mentioned, I think it was maybe Ryan mentioned this when he was talking, is just talking about climate change. If I think, and I don't do this enough either, even in my role, with family, with friends, talking about climate change, talking about the things we're doing and how that's making a difference, getting people excited about our natural systems, our natural ecosystems, our naturalized areas. And again, the overall, the biggest solution for climate change is the mitigation aspect, is reducing carbon dioxide emissions. To do that, again, that's a policy it's essential. That's a policy issue. So getting more folks voicing their, prioritizing climate change as an issue for policy, that's how we get there. That's how we actually get to mitigate climate change. So lastly, just thank you overall for allowing me to speak. I know it was a lot of information. Hopefully it was digestible. My contact information is here. Please feel free to reach out to me anytime. I mean, it seems like you all are doing a lot of great work in climate. So please reach out to me anytime if there's anything that you want to make me aware of that you're doing, because it's always great to hear what's going on. And if you ever have any questions, need resources, connections, anything like that. And again, I really appreciate you you allowed me to take up some of your time today at the meeting. Thank you very much.
Thank you very, very much, Trent. That was so interesting and so much really, really useful information, particularly there at the end, telling us things that we can do. One of the things is that you focused a lot on flooding. Some of the flooding is, as you said, from streams and rivers, and some of it is from extreme rainfall in short periods of time. And wondering, are there new technologies coming along, for example, to cope with a sudden rainstorm in an urban city?
There are technologies. So there's a whole host of different technologies that are, some I would consider more, consider like traditional engineering technologies, and of either expanding the ability to get water where it needs to go through drainage systems, or being able to reduce that surge of water through water capture systems, retention ponds, or large scale rain capture systems, things like that. There's also, of course, been a big push for green infrastructure solutions to that as well. And so there are more and more seeing municipalities adopt those sorts of solutions because they're relatively cheaper. They are aesthetically pleasing, of course, to see that, and they work. And so whether it be bioswales, rain gardens, things like that. So those are sorts of technologies, I guess we can call them, that the cities are adopting more and more. But again, we come to this issue of the disproportionate access, or the different access to those resources. So communities that may not have the resources to implement those strategies are sort of at the mercy of impacts. And even within one community like Champaign-Urbana, Chicago, Peoria, wherever we may be, we see still that green infrastructure, those kind of developments occurring in areas that are more affluent, that have more resources overall to deal with the impacts of climate change. So a more equitable distribution of that technology, implementation of the technology is just as important as building out the technology itself.
Yes. And then, of course, we're not all urban. A lot of us either living out next to farmers, or maybe we're part of the farming community. And as such, we've been hearing for many, many years that we've been killing the Gulf. Are there new technologies to hinder the loss of the nutrients? You were telling us these horrifying stories about how the sudden rainfalls can float all of the nutrients away and maybe stop the joy of having all this wonderful soil here in Illinois. Are there technologies to save it?
There are, I would call it practices more than technologies. We can think of technologies like, for example, a biodigester or bioreactor, where you dig a hole, fill it full of wood chips, and those are coming along, but those are fairly small scale right now. We're talking about majority of land use in Illinois that goes to a traditional, typically corn and soybean rotation agriculture. So I think more effective, especially in the relatively short time that we have to really solve these problems, is it's just better water and soil conservation. So expansion of riparian borders, prairie strips in cultivated fields. I can mention a more diverse rotation. So, for example, if you we have corn, which of course requires nitrogen application. Well, it's arguable, I suppose, but it most of the time requires nitrogen application. So a more diverse rotation of things like small grains. And again, grazing rotation can increase the overall soil health, which means less likely or less necessary to apply those nutrients onto the field directly. Also, the more wide-scale implementation of things like cover crops, it just has to happen. Cover crops, conservation tillage or no-till practices, those have to expand here in the Midwest to reduce the overall nutrient loss. So those things are really important to implement. And again, I would say those are more under practices than necessarily like any sort of individual technology.
Thank you. Is there any rationale that you can give us for why there's such a location variation in rainfall and flooding within a very small area? For instance, we saw 3 floodings of the Sangamon this year, but there was no flooding actually in Champaign-Urbana. Is there any explanation of why one place and not another? Why Bloomington? Why Gibson City?
When it comes to flooding, location matters. It does. So, for example, I live along the Sangamon and just outside of Mahomet, and we did see flooding along the Sangamon here, downstream of Monticello. I know it was pretty intense. Upstream in Fisher after the really intense Gibson City precipitation event. That's because that whole area drains into the Sangamon. Whereas in Champaign-Urbana, we didn't see that much flooding from that system because they didn't get 10 inches in 3 hours. So where you are located next to streams, rivers, the topography of your location, that all matters. It does when it comes to flooding. When it comes to intense precipitation, that doesn't matter at all. The fact that intense rainfall happened in Gibson City and not in Champaign-Urbana has nothing to do with any sort of differences between Gibson City and Champaign. It has to do with chance. And that's all it is. Same thing with South Bloomington. Actually, the CHAMP group here at the Water Survey ran some just kind of simplistic modeling, hydrologic modeling of if that Gibson City event would have happened over Champaign-Urbana, and what the what the depth of water in different parts of the city would have been like. And it was actually pretty humbling to see that because, parts of the water survey buildings would have been under, 3 or 4 inches of water, right? Major thoroughfares in Champaign-Urbana would have been completely impassable. So, when it comes to actual flooding, where you are does matter. When it comes to experiencing extreme precipitation events, that what happened in Gibson City is just as likely to happen or not happen in Champaign-Urbana or Bloomington or wherever. So that is really important to understand as well, that there are differences in how a community is impacted by flooding, but not to whether or not they're going to experience the impacts of extreme precipitation.
Thank you. And so to focus back on the farmers again for a little while, the emotional toll of the farmers not knowing what's going to happen and then suffering what does happen is very, very bad. And we're wondering whether weather windows, that is to say, when the soil is dry enough to plant, to harvest, to do all of the items the farmer needs to do, whether those weather windows are going to continue to appear or whether they're going to disappear. Is it going to become much harder for the farmers to do their job?
Yeah, so that's sort of the overall conclusion of ag impacts from climate change is it makes it just harder. It is not impossible. Right, you look at some places in Texas and California where it's debatable whether or not they can continue their agricultural practices at all in some of those places. Here, that's not the case. But what we've seen is an expansion of growing season, the growing season length, which is beneficial. But as you kind of mentioned, because of concurrent changes in precipitation, farmers are less likely to be able to take advantage of that longer growing season, those windows. And so decisions about fertilizer application, herbicide application, cropping rotation, fall tillage or not, those sorts of decisions become harder because they're in a compressed window, but also become harder because there's more impact from those decisions because of just overall higher stakes. And so this is something I didn't talk about before, but one of the public health implications of climate change is mental health from that. Yes. And I think farmers are one group that is, of course, we're acutely aware of how stressful farming is. And just the mental health strain of a year like, for example, 2019, when statewide yields were actually ended up being not too bad for corn and soybeans. It was a stressful year because there was so much delay in planting. There was a fear of delay in harvest. Folks didn't know what they were going to do. There was an issue with on-farm storage, and of course, natural gas and propane prices were through the roof. So kind of similar to what we're seeing this year with fertilizer prices. So all of that plays a role in that mental health stress. So again, yeah, ag has their own set of impacts for sure. But again, it comes down to those decision windows get compressed. It just makes farming overall harder, more stressful job, which of course is something that they don't need.
Yes. There are a number of people who have written in to say how much they have enjoyed the clear way in which you have talked about this and how fortunate that we feel that you are here to help us do what we can in this area. And we'd like to thank you for that. In the October 30th to November 7th issue of The Economist, there's an extensive special report on several aspects of climate change, and Eileen suggests that we should all have a look. You did mention our helping with rain gauge collection, but I'm wondering, since you are performing research in this such important area, whether you have citizen science projects that we can help you with. We have a weekly program that goes out from Amanda. And if you can send in to Amanda to tell her when you need 1 or 10 and what you need to do, we would be only delighted to help you.
Yeah, that would be fantastic. The biggest thing that I've been trying to do is get better collection of condition monitoring around the state. So, some of the CoCoRaHS observers who are on may participate in condition monitoring too. Once a week or so, they'd say, is it mildly wet, moderately wet? What am I seeing on the ground? That sort of thing. Formalizing that in a little bit of a better way to understand what conditions are looking like on the ground is really beneficial to me. Now, I've tried to sort of do this by plugging different avenues of folks who are, willing to do that. But if your community would be interested in doing something like that, again on like a weekly or once monthly basis, basically just telling me what it looks like outside your window relative to what you're typically seeing, or typically used to seeing. That would be fantastic because it's really difficult it's difficult enough to monitor what precipitation's like across a state as diverse as Illinois, but let alone what that actually means on the ground. So I can see 2 inches in Danville yesterday, but is it still really wet there? Was the soil so dry that it just absorbed in? What are people seeing? So that's really important.
So really, after precipitation, you would like to get data back every half week or week for quite a little while.
Yeah, and not just after precipitation, when we don't have precipitation. So when we're seeing drought conditions or extremely dry conditions, understanding, again, I can look at models or estimates of soil moisture, precipitation, stream, whatever it may be. But I don't know how people's, I don't really have a good idea necessarily everywhere of how people's, what they're seeing on the ground. Perhaps they're seeing no problems at all. Perhaps their mature sycamore is dropping leaves, and it is really important for me to kind of know that the actual impacts that are being felt.
Yes, yes. And so just a final thought. We talk about growing local, but what about not growing in California? If you look back at the old days, we used to be very important in vegetable growing. And then we started growing corn and soybeans, not for everyday eating. Should we actually be looking at more garden farming here in Illinois?
Well, we are blessed with some of the best soils in the world, and a pretty good climate for growing. Now we can't do 2-3 seasons worth of broccoli a year, like they can in California, but it is really important. So I mentioned, when it comes to food production, the resilience of that system is really important. It's really important that when we go to the grocery store, that the food that we need is there when we have it, that our food banks are stocked to. And so as we see climate change impacts intensify, which is inevitable in the next 30 to 50 years, California, with the major vegetable and fruit growing areas of the US, are some of the most heavily impacted, whether it be wildfires in California and drought or hurricanes in Texas. So it would behoove us to boost, the vegetable fruit production here in Illinois, because it can overall make us, again, more resilient to the food production system. But it has to be economically feasible too, and that's really important.
Yes.
So we still have an economic system that we have to work within. So that's really important as well. That it has to make sense for folks to, if they want to switch, a few hundred of their acres from traditional corn soybean rotation to something more vegetable fruit driven, and so that has to make sense economically as well.
Trent, thank you so much for your talk. We really, really appreciate it, and we will think hard about those messages that you have given us, and we would love to work with you in the future.
Thank you again, and like I said, I have my contact information. Please reach out anytime anybody ever needs anything. I really appreciate it.